It's part of the mission of the International Space Station to educate, and one piece of hardware is educating not only students but ground teams. Lori Meggs is at the Payload Operation Integration Center at NASA's Marshall Space Flight Center with more. Lori?
We're in a little different location today. We're actually a floor below the Payload Operations Integration Center, and Lisa Smith is the Mission Operations Lab training team lead. And Lisa, let's set the scene here. Tell us what we see behind us.
Okay, this is our laboratory training facility. It's a mock-up of modules, just like we have on Space Station. And it's filled with payload, facility racks, and some payload equipment. And so this is a place where we train our ground flight controllers, and so to make them familiar with the different facilities and the payloads that go on to Space Station so we can support the crew members once they're on board doing payload activities.
We talk a lot about experiments, but we have to have facilities too. And really this is timely that we're talking about, let me read this, the General Laboratory Active Cryogenic ISS Experiment Refrigerator. That's why we have acronyms. Glacier. It's pretty timely because Glacier just brought back samples on SpaceX 5. Let's talk about what Glacier is and what it does.
Okay, yes, Glacier came back on the SpaceX Dragon with some samples, and so this facility is a freezer, and the capability is from +4 all the way down to -160 cryogenic freezing. And so just as a point of reference, your refrigerator is around +2 and your freezer at home would be -18. And so experimenters use this to preserve and to transport the samples that they take on orbit so that they can bring them back down to Earth and the scientists can process them. And so we can get the science from what the experiments have done on orbit. So it's very important for us to have this facility here and to train our ground controllers so that they're familiar with the activities and so they can support the crew once they're on orbit running the activities.
So the Glacier can also be commanded from the ground, which is why it's vital, correct?
Oh, absolutely. The temperature can be commanded from the ground, so if we have different experiments that require different temperature profiles, we can command that from the ground. And the University of Alabama in Birmingham is the hardware developer, and they did this for the cold stowage group at JSC. And so in collaboration with Sharon Campana at JSC, I was able to bring the facility here on loan for 6 months. I actually worked for the University of Alabama in Birmingham prior to coming to NASA, and so I have a good relationship with them and the coast stowage team. And so it just really aids for us to be able to have this facility here and train our cadre, our flight controllers, on the different operations and the power and data and the connectors. So for the young engineers and the new to NASA and ISS, it sort of puts a face with a name, if you will. You can read about the payload and the facilities, but it's really good to have the hardware so that we can go and do hands-on training. So they get a feel for the connectors and opening of the door, the inside, and how you can reconfigure it to meet the needs of the scientists throughout the world.
So it's training ground crews here, but it's training astronauts in Houston, right?
Oh, absolutely.
Okay, and there's really another cool story about pretty much most of this lab and who built it. Tell us about Hunch.
Okay. Hunch is High Schools United with NASA to create hardware. And this was an innovative approach that an engineer at NASA had, and it started in 2003 with 3 high schools. And so we partnered with the high schools to develop the hardware and prototypes for us to have for the training. It's just a cost-effective way for NASA to have the hardware which we might not have otherwise, and it gives the high school students an opportunity that may not otherwise have to partner with NASA and develop hardware. They've a lot of different areas that they can go into, whether it's soft stowage and sewing, whether it's soldering, whether it's 3D printing. It's just a real good way for them to partner and learn the engineering and design phases that NASA goes through.
And let's talk about the high school that actually built this one. It was one of the first in the program.
Oh, right. It was in League City, Texas. It was Clear Creek School. And they partnered with 2 Alabama schools to build this. It was Huntsville Technology Center here and then Brewer High School. And so they partnered and built the hardware and delivered it to the JSC, and it was used for crew training to start with. And now we're able to borrow it for 6 months so that we can train our flight controllers here.
How cool is that for high school students to be building this type of hardware?
Oh, it is. It's just a real unique opportunity for them and for us too. And we provide our requirements to the coordinator here, and he goes and sees throughout the Southeast the different schools that we have. We partner with 23 schools in the Southeast and over 600 students. And we have an end of the year program, and they provide their hardware or their whatever they're providing to us. It may be drawings, it may be videos, and then they get to see and tour NASA and talk to the engineers here. So it's just a real cool opportunity.
Well, Lisa, thank you so much for this opportunity, and I'm going to go put my hands in the glacier. I won't put my lunch there, though,
Okay.
I promise.
All right.
And let's take a live look into the Payload Operations Integration Center today. Busy at work, and that will do it for us from the Payload Operations Integration Center at NASA's Marshall Space Flight Center. Now back to you at Mission Control in Houston.